Jet engines work by taking in air, compressing it, mixing it with fuel, and then igniting the mixture to produce a high-velocity exhaust stream. The force of the exhaust stream propels the aircraft forward, providing the necessary thrust to keep the airplane flying. In a typical jet engine, air is drawn in through the front of the engine by a compressor. The compressor compresses the air, raising its pressure and temperature. The compressed air is then mixed with fuel and ignited in the combustion chamber, creating a high-temperature and high-pressure exhaust stream. The exhaust stream is directed through a series of turbine blades, which extract energy from the stream to power the compressor and other accessories. Finally, the exhaust gases are ejected from the back of the engine at high velocity, providing the thrust that propels the aircraft forward. Jet engines are powerful and efficient, making them the preferred choice for commercial airliners and military aircraft. However, they are also loud and can contribute to noise pollution, so efforts are constantly being made to reduce their noise and environmental impact. Let's understand function of each part of jet engine that makes the aircraft to fly in air. Number 1. Fan. The fan is a key component of a jet engine that helps to increase the amount of air that enters the engine and provides additional thrust. Its main function is to provide a large mass of air to the engine's low-pressure compressor, which is responsible for compressing the air before it enters the high-pressure compressor. The fan is located at the front of the engine and is driven by the turbine section. As the fan rotates, it draws in a large amount of air and accelerates it, creating a high-volume, low-pressure air stream that is directed into the engine's intake. The increased mass of air entering the engine allows it to operate more efficiently, producing more thrust and improving fuel efficiency. Number 2. Diffuser. The diffuser is a component in a jet engine that helps to slow down and increase the pressure of the air entering the engine. Its main function is to convert the high-velocity, low-pressure air flowing into the engine into a slower, higher-pressure air stream that can be more efficiently compressed and ignited in the combustion chamber. The diffuser is typically located at the entrance of the engine, just behind the compressor. It is a conical or diverging duct that gradually widens in diameter and reduces the velocity of the incoming air. This process of slowing down the air increases its pressure, which makes it easier for the compressor to compress the air and Number 3. Multi-stage compressor. Multi-stage compressors are used in aircraft engines to achieve higher levels of compression and greater efficiency. A multi-stage compressor consists of several stages of compressor blades, each of which compresses the air a little more than the previous stage, resulting in a highly compressed air stream. Shape of compressor. Jet engine compressors are conical in shape because this shape allows them to efficiently compress incoming air. The conical shape of the compressor allows for a gradual decrease in the area through which the air flows, which leads to an increase in the air's velocity as it passes through the compressor. Number 4. Combustion chamber. The combustion chamber of a jet engine is a critical component that is responsible for the burning of fuel and the generation of high-temperature, high-pressure gases that power the engine. It is typically located between the compressor and the turbine in the engine's hot section. The combustion chamber is designed to mix fuel with compressed air and ignite it to produce a high-velocity stream of hot gases. Number 5. Ignition system. The ignition system of a jet engine is responsible for igniting the fuel and air mixture in the combustion chamber to initiate the combustion process. The ignition system typically consists of several components, including spark plugs, igniters, high-voltage electrical systems, and control circuits. Number 6. The turbine in a jet engine is a critical component that is responsible for extracting energy from the hot gases produced by the combustion process in the engine's combustion chamber. The turbine is typically located between the combustion chamber and the exhaust nozzle and is driven by the hot gases as they expand and flow through the turbine blades. The main function of the turbine is to convert the energy from the hot gases into mechanical energy, which is then used to power the compressor and other engine accessories, such as generators and hydraulic pumps. As the hot gases flow through the turbine blades, they cause the blades to rotate, which in turn drives the engine's shaft and compressor. Number 7. Exhaust nozzle. The main function of the exhaust nozzle is to convert the thermal energy produced by the combustion process into kinetic energy in the form of a high-velocity jet of hot gases. By accelerating the exhaust gases to high speeds, the nozzle produces a reaction force that propels the aircraft forward and generates the thrust needed for flight. Nozzle of jet engine that is responsible for accelerating the high-temperature, high-pressure gases produced by the combustion process and directing them out of the engine to produce thrust. The exhaust nozzle is typically located at the rear of the engine and is designed to control the flow of the exhaust gases and increase the velocity of the gases as they exit the engine.